NSPIRE program, which is a graduate research fellowship program at WSU funded by the National Science Foundation, gives all the students in the program an opportunity to go on a 3-month fellowship at a government agency or other institution of their choice. And during that fellowship, they work at the intersection of science and policy. My research focuses on high elevation lakes and national parks, so I'm interested in how nitrogen deposition affects the algae in those lakes. The nitrogen deposition, so nitrogen in rain, precipitation, and dry particles can be a fertilizer and affect the algae in those lakes.
I think the coolest thing about my research is the location I get to work in. So I work up in these amazing alpine meadows filled with wildflowers above tree lines, so you can just see for miles in the Cascades. So I'm looking at the impacts of nitrogen pollution to these kind of more vulnerable, susceptible alpine meadows. These systems are more vulnerable or more susceptible to nitrogen pollution than we previously thought. My research has shown that even small amounts of an increase in nitrogen pollution can have major impacts on the amounts of nitrogen being lost to these watersheds and the amounts of greenhouse gases these systems produce.
What I'm really interested in is trying to understand where that extra nitrogen that's causing problems is coming from. And so to do that, I use a combination of analyses in the laboratory as well as some computer models to try to figure out where it's coming from and what kind of sources it's coming from. In the Snowy Range in Wyoming, we can see a profound effect coming from the Four Corners area where there's a lot of coal fire plants. Another example is in the Columbia River Gorge. I can see very specific differences in the kinds of sources contributing, whether the air is flowing up the gorge from the Portland-Vancouver area or down the gorge coming from the Columbia River Valley and the Yakima River Valley.
I look at rangeland ecosystems and I do a lot of modeling work, meaning I use a computer to look at how the environment works, and it's difficult to do that in real life, so we use a computer to simulate what could happen. And so by looking at rangelands, we can look at the impacts of potential changes in climate, or changes in rainfall or temperature, and also different management styles. And so the most exciting part of my research is actually working with ranchers, for example, and different stakeholders, and learning about what they do on their land and how I can include that information in my modeling work.
And my project specifically is miniaturizing a system so we can go from biomass to biofuels right in the classroom. I came to Washington State, a large portion of that reason was because of NSPIRE, and it's really interesting because my project is not very obviously focused on nitrogen, right? But actually in gasification reactors, a lot of input biomass has nitrogen content in it. I love my work. It's wonderful. And I really appreciate it because it gives me a good slice of the lab, but it also gives me a lot of opportunity to engage with students and to learn where they're struggling, and then to use my own expertise and try to come up with solutions to help them.
My research has been on greenhouse gas emissions of carbon dioxide, methane, and nitrous oxide, and also carbon and nitrogen cycling from agricultural streams, trying to essentially instigate better management practices on land to then affect water quality and also ecosystem health to streams, lakes, rivers, and the ocean.
So my research is interdisciplinary, and one of the core focuses is ammonia emissions from beef cattle production. The NSPIRE program itself is, in terms of how its coolness or its uniqueness, is about interdisciplinary work. And so while my research and the facets around ammonia production are just one component, I've been learning about how nitrogen and other nutrients cycle through atmosphere, terrestrial, and aquatic ecosystems.
Actually, I just came to work at WSU because my advisor's like, well, come back, and we're doing really, really cool work on imaging roots. So you get to see stuff that nobody's seen before. So basically we're taking scanners, office scanners, and sticking them in the soil and growing a root next to it. And you get to watch that develop. And so you get to see things probably that nobody else has seen before. NSPIRE is taking scientists and making them hopefully boundary spanners. So making you able to communicate with policymakers and the public, and then hopefully the idea is that our public policy then is scientifically informed.
Right now, we understand that problems are not isolated to our disciplines alone, but instead, like, long-term solutions have to come from a consortium of researchers. And a collaboration of researchers coming together to actually say, yes, like we recognize these problems exist in the environment, in the world, and we want to use each of our expertise in our own way to help find solutions for those problems.
I'd always thought getting a PhD meant you had to teach and you had to do research at some sort of university, but we saw lots of different people working at this intersection of science and policy, looking at the application of science and/or how can we use science to better inform decision making.
I think the fellowships have exposed us to a lot of really valuable experiences working in government agencies, understanding how policy and science interact, how science is used to inform policy, create policy, implement policy, and has given us a lot of relevant working experience for our future careers.